in today's lesson. Today we're going to look at continuous growth or decay continued. Anyway, I'm just basically going to look at a couple examples of the idea of continuous growth and show you a few little tricks of manipulating the equations and solving our answers. In this first example that I've chosen, it's about a population of rabbits and is presently 3,000. Decreases by about 12.4% each year. The population in 7 months is what? And we're to use continuous growth. So how do we set this up? This is going to be an example of a loss or decay, and we're supposed to use continuous growth. So we know our formula basically looks like this. Final population or amount equals starting population or amount times e to the I, which is the often referred to as the interest rate. Some books have the variable r here simply for the word rate. So I or r, it's the decimal form of this annual growth rate times the amount of time in years. And that's going to give us our answer. So for this particular problem, A will equal 3,000 times E to the decimal version of 12.4, so 0.124 times. Now, because this is a loss, one little thing I neglected, it's got to be negative. You're losing that amount. If this were to be positive, it would imply a growth of 12.4% each year. And 7 months. Now, how do I put that in years? Well, that would be 7 out of 12. 7/12. So no big deal for the calculator. All I got to do is put all this stuff in there. And 3,000 times e raised to the negative 0.124 times 7 divided by 12, close the brackets, and we get 2,790.66 if I go to 2 decimal places. Of course, you may want to consider rounding that. Since we're talking about rabbits, you may round that to 2,791, and that would be quite understandable. Okay, so that's this first question here, and I think probably at this point you're going, well, that's nothing new. Why did he make this a separate lesson? Well, I'm going to take this now, same setup, only this time I'm going to ask a different question. So, we're still dealing with the rabbits. We're still losing 12.4% annually. We're going to use continuous growth to ask the following question. When does the population reach 500? So, very important is that you set this up a little bit differently. This time we know our final amount or population. So 500 rabbits equals our starting population of 3,000 times e to the growth rate, which is a loss, so negative 0.124. And then I just put times t. Here's what I don't know, the amount of time. That's what we're looking for. When does the population reach, or how long into the future? So we're going to figure out what t is. How many years does t have to be? To solve this, I'm going to start off by dividing both sides by 3,000. So 500 divided by 3,000 equals e to the negative 0.124 times t. This, of course, I would put into lowest terms, but as well, I'm also going to take logs of both sides. And the reason is that our unknown, what we search for, is acting as an exponent. So we're going to take logs of both sides. Now here's the trick. Because we're dealing with continuous growth, I'm going to take natural logs of both sides. Now I also put the 500 over 3,000 into lowest terms. Now over here, when I take natural log of this, of course the advantage is that the exponent stuff can be brought out front. So I'm going to do that on the next step here. So we have now negative 0.124 times t times natural log of e. Now here's why we picked natural log, because natural log has a base of e. So this is saying e to what exponent would equal e. In other words, natural log of e is what? Well, natural log of e is just 1. Okay, again, e is our base, so e to what exponent equals e? Well, e to the 1. So this whole thing is simply 1. So it just kind of disappears. You can almost just erase it, but I won't, because you'll ask yourself, well, where did that go? So I'm just going to leave it. But it does essentially disappear. So to solve for t, I merely divide both sides by negative 0.124. So here's what I end up doing on the calculator. Natural log of 1/6 divided by negative 0.124. And that's going to give me the amount of years. Now I did this ahead of time, and so the answer that I got was about 14.45 years. Now I guess I should put in years. Okay, so that's the last little bit as far as continuous growth. Catch you later.